From Cape Canaveral in Florida, this is Falcon 9 launch control at T-minus 1 hour, 25 minutes, 15 seconds and counting. The countdown for the launch of the Falcon 9 with the Dragon capsule bound for a rendezvous with the International Space Station is on schedule for a liftoff at 4:55 a.m. Pre-launch activities have been underway at Space Launch Complex 40 since 9:30 p.m., at which time the Falcon 9 and the Dragon capsule were powered on. Shortly afterwards, there was a vehicle verification with the Tracking and Data Relay satellite system, as well as the Ground Tracking Station network. The call to stations for the SpaceX launch team in preparation for fueling occurred at 12:45 a.m. This is the terminal phase of the countdown, which is 4 hours and 10 minutes in duration, and there are no built-in holds. Loading of liquid oxygen began at 1:05 a.m., and the RP-1 fuel followed 10 minutes later at 1:15. There was then a test of the first motion sensor in preparation for the liftoff, which occurred at 1:25 a.m. The S-band telemetry and video transmitters on the rocket have been checked out, and the flight termination system checks with the Eastern Range have been completed. Upcoming at the T-minus 1 hour mark will be a weather briefing from the launch weather officer Mike McAleenan from the 45th Weather Squadron. The launch computer's automated terminal countdown sequence begins at T-minus 10 minutes. After liftoff from Complex 40, Dragon will begin its journey to the space station. Just after 10 minutes after the liftoff, the capsule will reach its preliminary orbit, deploy its solar arrays, and begin a carefully choreographed series of engine firings to reach the station. At T-minus 1 hour, 23 minutes, 23 seconds and counting, this is Falcon Launch Control. This is Falcon Launch Control at T-minus 1 hour, 17 minutes, 40 seconds and counting. Joining us here at our Public Affairs Console is Alan Lindenmoyer. He is the NASA COTS Program Manager, and COTS being the Commercial Orbital Transportation Services Program. And Alan, welcome. And I know you've been working on this for quite some time, and I was wondering, what is it like to work with a completely new launch services company? I thought maybe you could give us an example of what the learning curve has been like, both for NASA and for SpaceX working together.
Oh, right, sure, George. I would say there was a lot of learning by both sides as we learned to work together. On the NASA side, I think we had to get used to a different level of documentation. We're used to receiving a lot of details and all of the data deliverables that we usually review with our contractors. And what we found was with SpaceX had a different approach. Their documentation was more electronic, not so much on the written paper all the time, although when necessary, of course, it was. But I think what we were learning is it became much more effective to have face-to-face meetings, having meetings with the technical engineers and the experts, and I think that became much more effective for us instead of looking for a large volume of documentation that we were accustomed to. So that's something that we were learning on our side. I think SpaceX was learning a lot from NASA. Of course, we were sharing a lot of our technical information throughout this period. But recently, running our joint simulations, I think it became very clear that learning how to fly a very complicated spacecraft to the space station is quite a challenge. And I think the simulations that we executed with SpaceX were very, very helpful and uncovered things that really needed to be discovered and worked out early. So I think this joint testing, the joint simulations, learning how to fly with the space station, because it's not always exactly where you think it would be, and then you had to react to that and make sure you had the tools to turn around and make sure you had all the information you need to complete this operation. So a lot of learning. I think it was a great experience on both sides.
Well, Alan, we have some animation now that we would like for you to explain to us what's occurring, because this is pretty much from launch right up through splashdown. So if you could tell us what we're seeing.
Okay, sure. Well, a couple weeks ago we just saw a beautiful morning launch. I think tonight we'll see a even more spectacular night launch. And then about 3 minutes into flight, the main engines will cut off and we'll see the separation of the first and second stages. And then we'll see the ignition of the second stage. Then about 10 minutes later, we'll see the separation of the Dragon and its trunk. And approximately 2 minutes later, the solar arrays will start to deploy. Over the next 24 hours, they'll be phasing to the space station, doing some maneuvers and checkouts. The second day will be a flyby, and then if all goes well, on the third day we'll see the Dragon do the final approach to the station, be captured by the arm, and berthed to the forward node, bottom side of the forward node there. And this operation will take about 8 hours from the final approach to capture and then the actual berthing of the Dragon to the station. We should see that on May 22nd. It'll stay on orbit for about 9 days, do the cargo transfer. We'll take cargo out of the Dragon, and then there'll be some cargo coming back home. And scheduled now for May 31st, we'll see the arm unberth the Dragon, basically reversing the process. And the Dragon will be released, and approximately 2 to 4 orbits after the release, we'll see the Dragon re-enter It'll do its departure maneuvers. We'll see the re-entry. And then the descent and splashdown off the coast of California.
Well, Alan, thank you very much. And I know you're looking forward to the launch tonight, but as much the birthing coming up, which is a real milestone that I know that you've been working with SpaceX very closely with. So best of luck. And
thank you very much, George. Things are looking great, so we're looking forward to a great launch tonight.
Thanks very much. We're at T-minus 1 hour, 11 minutes, 54 minutes and counting. This is Falcon Launch Control. This is Falcon Launch Control, T-minus 1 hour, 10 minutes, 5 seconds and counting. Joining us here is Mike Horkachuk. He is the NASA COTS Program Executive. And Mike would like to begin by asking you a little bit about the fact that this is a commercial launch, but yet it's a NASA mission. So I was wondering maybe you could explain how it is that NASA works with SpaceX to assure that NASA's mission objectives are met.
Okay. Well, we had some top-level objectives that were defined in the Space Act Agreement with SpaceX. And then as we went through the design review process, we refined those and made them more crisp and more specific. Eventually, at the demo readiness review, we signed a joint document that listed out all the mission objectives for C2 and C3 and the success criteria for each one of those objectives. And then I also have the SRB ships with radar on them going up the East Coast to watch the mission and see some of the key critical events as they're happening during the launch. As the vehicle gets closer to space station, there'll be the Mission Operations Directorate at Johnson Space Center working with SpaceX, looking at the data from the spacecraft and making sure that a number of demo objectives that we've defined are all performed correctly and the vehicle is operating and it's healthy before coming in for final approach to space station.
Now, has NASA worked with SpaceX some in developing the Falcon 9 or the Dragon?
Yeah, we've been in the development process with them from the beginning. At various times, we've helped them with technical experts from Houston, Johnson Space Center, Marshall Space Center, Ames Research Center, helped them with the thermal protection system on the capsule. The Marshall folks obviously helped them with some of the propulsion areas and base heating and other aspects of the vehicle. So we looked over the design through the whole process and pointed out areas that we had experience with in the past.
Well, Mike, let's switch gears here a little bit. We have some video of the cargo being loaded into the Dragon capsule that we're taking up to the station. So maybe you could tell us some of what is going up that's on board, some of what we're seeing here that's going up.
Okay, you see obviously a bag of food items. Those are cargo transfer bags, CTBs, crew transfer bags. They are generally used to pack items, and they have handles on them so the crew can easily maneuver them back and forth between vehicles. They're getting loaded through the side late access hatch in this case, and here they're installing them into the cargo racks that are outfitted inside the capsule. They're strapped in for launch, and they'll also be strapped in by the crew for re-entry. And then the bigger bags get loaded up and lifted into the capsule. You can see here by crane and up through the forward hatch on the capsule, which is the CBM hatch, the one that mates up to the space station. You can see the CBM there up on the top, that gray looking portion right along the top edge of the capsule. So the bigger bags are for larger items in the future, larger ORUs, or just being able to carry a number of smaller bags all at once. And then should be showing more details of the intermodule ventilation inside the capsule there. And then they're getting ready to install the side hatch. On future missions, there'll actually be late access cargo that's loaded through that side hatch within 24 hours of launch. Some critical science experiments, and you can see on this hatch that there's also a mounting location for some freezers that we use to take up and return science samples. Here they are doing the final closeout on that hatch.
Well, Mike, we'll be talking with you after launch as well, getting an update on how things are going. So in the meantime, thank you very much, and best of luck for the remainder of the count, and we'll talk to you once it's in space.
Very good.
We're at T-minus 1 hour, 5 minutes, 10 seconds, and counting. This is Falcon Launch Control. This is Falcon 9 Launch Control, T-minus 1 hour, 1 minute, 56 seconds and counting. The next activity coming up in the countdown is the launch weather briefing. This will be done by Falcon 9 Launch Weather Officer Mike McAleenan from the 45th Weather Squadron. And that briefing occurs at exactly launch minus 1 hour, so that is about 1.5 minutes away from now. So we'll stay tuned for that, and we'll be back after the weather briefing and talk with Gwen Shotwell, who's the president of SpaceX. At T-minus 1 hour, 1 minute, 17 seconds and counting, this is Falcon Launch Control.
check. 1, 2, 3, 4, 5.
This is Falcon 9 launch control at T-minus 55 minutes, 6 seconds and counting. Joining us now is Gwynn Shotwell, the president of SpaceX. And Gwynn, we'd like to start by asking you what it's been like to work with NASA, given that this is an entirely new way of doing business for the agency. And in what ways maybe has NASA been able to help?
Yeah, the relationship has been extraordinary, George. We started this adventure in August of 2006, and NASA has been extraordinarily helpful as well as supportive. Some of the specifics, we've had a number of the centers help us with our aerodynamics work, some testing as well. They helped us develop the PICA, the material, phenolic impregnated carbon ablator material that we have for our heat shield. They've been helpful in many of the other development areas on the Dragon spacecraft itself.
Okay, we're looking now at some video of what's been going on to get the Falcon 9 and the Dragon ready for launch. So if you could kind of talk us through the video and tell us what it is we're seeing.
So what you're seeing right here is the first stage approaching the hangar at our launch facility, Launch Complex 40. That arrived from our Texas test site where it was proof tested. Prior to being in Texas, it was obviously produced in our Los Angeles facility. And there you see it. And here is the Dragon arriving. Coming into the hangar in the clean room there. That's it there in the silver box. Pulling off the container that protects it during the ride. We double shrink wrap it, make sure it stays dry. So we're obviously moving it from its transport fixture onto its processing plate in the hangar. So this is in a separate part of the hangar from the Falcon 9 that's suited for to handle hypergalls. Because Dragon, the fuels are NTO and MMH. So it has a special handling area. And then you see the fixturing there on the right. Dragon's going to be lifted up and over that onto what we call the trunk. So the capsule itself is pressurized. That berths with the station and the hatch opens. And then the supplies that go into the space station are pulled from inside the capsule. The trunk is unpressurized, has a view to space. See, we're lowering Dragon down on the trunk right now. See, the trunk is that white structure below Dragon. There you see it. So unpressurized cargo would go in there, something on what's called a FRAM, a NASA-developed flight releasable attach mechanism. There is no external cargo on this flight, just pressurized cargo. There we go. You're taking a look at the second stage on your left and the inner stage right in the middle. There's Dragon. So we'll lift you see we're lifting the structure there, and then it will rotate to horizontal and then be mated to the second stage. You see they're lining it up there. It's got to be precise. This operation takes almost a whole day.
What's up? Out there. So do count, do 220. Alright, let's do another 10-20.
So this rollout is for our wet dress rehearsal. and static fire this past April. As you can see, we roll out in the horizontal position. We do not process our vehicle vertical.
No.
So slowly we move towards the pad, and then as we rotate to vertical, the fluid lines get engaged automatically, and then there are some hand connections as well. So that structure that you see the vehicle on, we call that the erector. And then the launch base itself is that large gray structure on the back end. See those giant towers? They're actually much taller than the vehicle itself. Those are lightning towers of critical importance here at Cape Canaveral.
Dragon's auto idle. Dragon to startup.
This operation that we're looking at right here is for a static fire, which is the final, there we go, the final systems test in prep for launch. Very much like a pilot runs its engines to test how things are operating. We want to run that final test before we launch.
Well, Gwen, after we launched today, where will you watch the rendezvous and berthing operations from?
I'll be at our headquarters in Hawthorne for that.
In Hawthorne. So
yes.
As soon as we launch, then you're headed to the West Coast.
That's correct.
And so then again, that's where you'll watch the splashdown from.
That is correct.
Well, again, thank you very much. It's I know we're looking forward to, especially the first hour and a half after launch today. There'll be a lot of important things happening with the Dragon that will let us know we're clearly on the way to the rendezvous with the station. Thank you very much for coming by.
Thanks for having me, George.
And we're at T-minus 48 minutes and counting. This is Falcon Launch Control. At T-minus 43 minutes, 17 seconds and counting. This is Falcon Launch Control. NASA's solid rocket booster recovery ship, the Freedom Star, has been repurposed for use on this mission. Onboard cameras that used to track the space shuttle have been installed. They'll be used to capture images of the Dragon capsule and the solar array deployment. We tagged along on its voyage out to sea in preparation for the SpaceX launch, and here's more.
On a sunny spring morning, the crew of the Freedom Star gets ready to head out from the Cape Canaveral Air Force Station.
All lines are in, ready to depart dock. Get on the way for sea.
It's NASA mission, training for the dawn of a new day in space travel, capturing the launch of the first commercial spacecraft going to the International Space Station.
Well, very similar to what you see in front of your high-definition television set at home. We're looking at getting very high spatial resolution, high-definition quality of visual imaging during the launch, as well as high spatial resolution thermal imaging from an infrared camera.
The Freedom Star, once used to recover shuttle rocket boosters, is now outfitted as a floating high-tech radar and camera platform. Inside a huge metal clamshell is a mobile optical system on a gyroscope-like tracking mount. During launch, the system will be focused skyward to take images of the SpaceX Falcon rocket and its Dragon capsule as far as 200 miles away.
We have several key events that will occur during ascent. So we have one ground station at Daytona Beach, Florida that will capture early events and ascent. And then we have a second tracker that will be located on a ship in the North Atlantic.
That will be the Freedom Star that will capture later parts of the trip, including deployments of the capsule and solar panels. Even with high-powered radar, telescopes, and cameras, and a team that has had success in taking thermal snapshots of the space shuttle at Mach 18, imaging the launch will be no easy task.
It's like standing and looking through a soda straw and trying to capture and see a bird flying through that soda straw.
Then imagine that soda straw bobbing on a boat off the northeastern coast of the U.S. in seas that could swell up to 20 feet. The crew can only hope that the weather at launch and ascent is more like a day at the beach and not the perfect storm.
T-minus 40 minutes.
GC, are you ready for vehicle release setup?
GC is ready.
Copy that. Entering 1 to proceed. Vehicle release final setup is started. CE, prepare for the terminal count poll.
En route.
Copy that. Proceeding.
RC.
Prop stage 2 fuel bleed has already been performed. Are you good to skip?
Prop's good with that.
Copy that. Entering 0 to skip stage 2 fuel bleed.
OSM, first step 57.1, verify flight hazard area roadblocks are established. Verified. Copy.
LC, flight hazard roadblocks have been established. Entering 1 to continue with Yoda.
A supplemental weather brief is not required.
Copy that. Entering 0 to skip. RC, report the downrange tracking station status.
Downrange tracking network's ready to go.
Copy that. Entering 1 to proceed. Rock, report range status.
Range status is proceeding.
Copy. Proceeding. GNC, verify winds aloft are acceptable for loads and control authority, and verify ground winds are within launch limits.
Winds aloft are acceptable, and ground winds are within launch limits.
Copy that. Entering 1 to proceed. Flight software, verify consoles have no critical errors.
That's verified.
Copy that. Proceeding.
This is Falcon Launch Control, T-minus 34 minutes, 55 seconds and counting. We'll look at some video now taken just after 3 a.m. this morning when the strongback was pulled back from the Falcon 9 rocket in preparation for the final part of the countdown operations. And while we're watching that, we'll continue to listen to our launch conductor, Brian Childers from SpaceX, as well as the SpaceX launch director, Brian Mosdell, as they work through our procedure to get us to a 4:55 a.m. launch this morning. Our weather forecast has been updated. We just have a 20% chance of not meeting our launch weather criteria this morning. At T-minus 34 minutes, 13 seconds and counting, this is Falcon Launch Control. We're back live with a live picture of the Falcon 9 on Launch Complex 40 at Cape Canaveral. 32 minutes until our liftoff time. The Falcon 9 with the Dragon spacecraft is 157 feet in length and 12 feet in diameter and weighs 735,000 pounds. 9 SpaceX Merlin engines power the Falcon 9. The rocket is held down on the pad and not released for flight until all propulsion and launch vehicle systems are confirmed to be running properly. After liftoff, the first stage will burn for 3 minutes before separating from the rest of the rocket. A single Merlin engine on the second stage will burn for 5 3/4 minutes before the Dragon separates from the Falcon 9, 9 minutes 35 seconds after launch. After the liftoff, mission control for the Falcon 9 and the Dragon spacecraft will be at the SpaceX Mission Control Center in Hawthorne, California. Dragon will have a link with a series of ground tracking stations around the world and also will be using NASA's Tracking and Data Relay satellite system. During the Dragon's approach to the International Space Station, NASA Space Station Mission Control Center in Houston will also be involved in the approach and berthing activities. At the time of launch, the International Space Station will be located about halfway across the North Atlantic Ocean between Labrador and Ireland. At T-minus 30 minutes, 32 seconds and counting, this is Falcon Launch Control. This is Dragon Launch Control at T-minus 25 minutes and counting. No problems being worked in the countdown at this time. We're on schedule for a 4:55 a.m. launch, and the weather is green. All of our downrange tracking assets reportedly go. The Dragon capsule on this test flight will transport over 1,200 pounds of cargo to the International Space Station, including science experiments, food, water, and clothing for the astronauts, and even a laptop computer and its accompanying accessories will make the journey. Dragon will spend about 18 days attached to the space station, and over the period of a couple of weeks, the astronauts will spend a total of about 25 hours unloading the cargo. They will then load over 1,300 pounds of equipment and expended consumables aboard the Dragon to be brought back to Earth. Dragon is actually capable of carrying up to 7,300 pounds of supplies to the space station. For its return, for approximately 4 hours after Dragon leaves the station, Dragon will conduct its deorbit burn, which lasts about 7 minutes. It then takes about 30 minutes for Dragon to re-enter the Earth's atmosphere and splash down in the Pacific Ocean about 250 miles off the coast of California. At T-minus 23 minutes, 33 seconds and counting, this is Dragon Launch Control. This is Falcon Launch Control, T-minus 20 minutes, 20 seconds and counting. We're going to go now to the International Space Station control room at the Johnson Space Center in Houston, where our ISS commentator Brandy Dean is standing by to give us a status of the readiness of Houston to support the flight.
T-minus 20 minutes.
LC, verify all previous auto and procedures.
Thanks, George. Good morning and welcome to Mission Control Houston, where the team here in the International Space Station Flight Control Room has been following along with preparations for tonight's launch and anticipating the planned demonstrations that will hopefully lead to the first docking of a commercial vehicle with the International Space Station on Tuesday. Leading the team here at the Johnson Space Center is Emily Nelson, the Orbit 1 flight director for today. However, assuming all goes as planned this morning, Holly Ridings, the lead NASA flight director for the SpaceX demonstration mission, will be taking over once the Falcon 9 gets off the ground. In preparation for today's launch, the team here in Houston has already given their go for launch after a no-go poll here in the room. That verified that all of the systems that would be used for docking are indeed ready to be called into action, and the ground network connections used to connect Mission Control in Houston with the SpaceX team in Hawthorne, California are in good order. This launch and the upcoming docking of the Dragon capsule to the International Space Station are the product of many years of preparation on both the NASA and SpaceX side, and the two groups are prepared now to function as one team. Awaiting the Dragon and its cargo, some 1,014 pounds of food, clothing, and supplies. In space is the newly expanded Expedition 31 crew. Commander Oleg Kononenko and flight engineers Don Pettit, Andre Kuipers have been anticipating and preparing for the Dragon's arrival for some time now, and they were recently joined early Thursday morning by new crewmates Gennady Padalka, Sergei Revin, and Joe Akaba, who have made it just in time to witness the historic docking firsthand. The International Space Station will be about 249 miles above the North Atlantic Ocean between Labrador and Ireland at the time of the Falcon 9 launch, coming up now in just 18 minutes. Once it has launched, of course, the Dragon capsule will begin its journey to the space station, performing a series of tests as it makes its way there to prove that it will be able to dock safely with the station when the time comes. The Dragon will be demonstrating its absolute GPS system using global positioning system satellites to determine its location, conducting a free drift demonstration to allow the spacecraft to float free with all of its thrusters inhibited, and then perform a demonstration of its abort capability to ensure that it can move away from the station if necessary. This has all been tested on the ground and verified by NASA, but now will be validated on orbit before the systems are used in a safety-critical situation near the space station. Assuming that all goes well, Dragon will be ready on Monday for its fly under of the International Space Station. That'll be the first time that the station has the chance to communicate with the Dragon, and the first time that the crew on orbit will send commands to Dragon and get a response. Dragon there will perform a series of burns on Monday to bring it to a point 1.5 miles below the space station and establish communication with the space station to perform a test of its relative GPS using a relative position of the spacecraft to the space station to determine its location. While it's nearby, the crew will also turn on a strobe light aboard the station to verify their ability to send the vehicle commands. That's going to be important on Tuesday when it's time for them to bring the Dragon in for docking. Once these fly-under tests are complete, the Dragon will fire its engines and begin a loop around the International Space Station at a distance of 46 miles and get set up for its chance to re-rendezvous with the space station on Tuesday. Again, assuming all goes well, on docking day, the Dragon will again be moving into position 1.5 miles below the station. The go is given by the team here in Mission Control. A burn will be performed to bring the vehicle within less than 1 mile of the station, and then there will be another go-no-go decision in Mission Control before it moves into 820 feet for another demonstration, this one of its LiDAR system. The flight control team in Hawthorne will then command the Dragon to approach the station, and it will move into 720 feet, and after another series of tests performed with the help of the crew and several more go-no-go decisions, the Dragon will be finally ready to dock with the International Space Station. Docking will be performed using the space station's 58-foot-long robotic arm by flight engineer Don Pettit with help from flight engineer Andre Kuipers. They'll use the arm to grab onto the Dragon once it's at a point 32 feet away from the station, and then bring it in for a berthing to the Earth-facing port of the station's Harmony node. That's scheduled to take place at 10:20 a.m. Central Time on Tuesday, and the crew has been practicing for this task since before they left Earth in December. From there, it'll be a matter of opening the hatches between the Dragon, and the crew will begin work of unpacking its cargo, a task that's scheduled to take about 25 crew hours in all. So we'll be looking forward to all that here in the International Space Station Flight Control Room following this morning's launch, now just 15 minutes away. This is Mission Control Houston. Back to you, George.
This is Falcon Launch Control, T-minus 15 minutes and counting. We're only about 2 minutes away from hearing the launch team pick up with their final polls and readiness to go into the automatic countdown sequence, which starts at T-minus 10 minutes. We're not working any issues. The weather is favorable. The range is go. So we are still targeting a 4:55 a.m. liftoff of the Falcon 9 rocket this morning. At T-minus 14 minutes, 32 seconds and counting, this is Falcon Launch Control.
T-minus 14 minutes. Stand by for the final poll at T-minus 13 minutes. All stations verify ready for launch. All stations acknowledge. FTS.
FTS ready.
Prop.
Prop ready.
AVI.
Avionics ready.
GNC.
GNC ready.
Ground.
Ground is ready.
VC.
VC's go.
GC.
GC's go.
DC.
DC's go.
RC.
RC go.
OSM. OSM.
OSM go.
ROT.
Range is ready.
CE.
CE is ready.
LD.
LD is go.
MD.
MD's go.
LD, verify go to initiate terminal count.
You are clear to proceed into terminal count.
T-minus 12 minutes.
GNC, prepare for the final print INAV command.
GNC ready.
This is Dragon Launch Control, T-minus 11 minutes and counting. The International Space Station is flying over Florida right now. In just about 50 seconds, we'll be picking up with the automated countdown sequence for the last 10 minutes of the flight. We're continuing to count down toward a 4:55 a.m. liftoff. We're now at T-minus 10 minutes, 36 seconds and counting. This is Falcon Launch Control.
Idle sequence. VC shall not abort the idle sequence after T-minus 10 seconds, and operators shall not call a hold after T-minus 15 seconds. If a hold is called, all operators proceed to the terminal count abort contingency procedure in section 10.59. Attention all personnel, stand by to pick up the count. T-minus 10 minutes and counting on my mark. 3, 2, 1. Mark. BC announced the idle sequence has started.
Dragon terminal count and F9 terminal count have both continued.
RCO, confirm the clock is counting.
Water deluge setting up.
Stand by on FireX.
Standing by.
RCO, confirm the clock is counting.
Clock is counting.
OSM, set launch enable to flight.
Switching to flight.
Pre-valves are coming open, aux bleeds are open. We are now chilling in the engines.
Prop confirms all pre-valves open.
T-minus 9 minutes.
Next event, Dragon goes to internal power at T-minus 8 minutes.
T-minus 8 minutes. T-minus 7 minutes.
The next major command will be to direct the flight computer to begin its final alignment. That occurs at T-minus 6 minutes 17 seconds.
Vehicles in self-alignment.
T-minus 6 minutes.
Stage 2 TVC bleed has started.
T-minus 5 minutes.
I don't know. Vehicle and catapult systems are setting up for
What?
Stage 1 and Stage 2 are going on internal power.
Telemetry.
We're on internal power on Stage 1 and Stage 2.
Telemetry and video transmitters now being turned on.
Vehicle release auto sequence is starting.
T-minus 4 minutes.
The
Ground TTEB system setting up.
vapors from the cryogenics surrounding the base area of the launch pad.
FTS on internal power.
S2 TVC motion complete.
We're about to terminate LOX topping.
Pre-valves are coming closed.
T-minus 3 minutes.
LOX load is ending nominally.
FTS, verify FTS is armed.
FTS is armed.
SpaceX Launch Director Brian Mosdell is
First
about
and
to give
second
his
stage
status.
fuel trim valves are in their flight positions.
LD, verify go for launch.
LD is go for launch.
Next, we'll have a go from the range.
Stage 2 heaters is ending nominally.
Rock, verify range go.
Range green.
T-minus.
Pre-valves are coming open for one last engine chill. Helium load is ended nominally.
And at T-minus 1 minute, the flight computer will be commanded to the startup state.
Engine purge ISOs open.
First stage engines are chilled in.
Vehicles in idle auto.
T-minus 1 minute.
Vehicles in startup. First and second stages are pressing.
First stage TVC motion looks good.
T-minus 30 seconds.
Standing by now for taking the tanks to flight pressure and activating the pad deluge water system.
T-minus 20 seconds.
20 seconds. The main engine controller commands will give the command to start the engine sequence at T-minus 3 seconds. We're at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and liftoff. We've had a cutoff. Liftoff did not occur. We've had a launch abort.
Terminal count launch abort.
We've had a launch abort
BC
standing
terminal
by.
count sequence have not already aborted. Verify the flight computers are not startup.
We did not get confirmation from the first motion sensor that liftoff occurred.
BC verify flight computer is not in startup.
Flight computer is not in startup.
Flight computer is not in startup.
If fire present at the launch mount.
Copy.
OSM, verify you're ready to safely FTS.
OSM, verify ready to safety FTS.
Copy.
Right now the vehicle is being safed. The ignition sequence had started, but there was a cutoff.
BC, verify all computers are in manual mode.
It's verified.
BC, close the engine pre-valves and open the aux bleeds.
Pre-valves are closed, aux bleeds are open.
BC, verify S2 internal, S1 internal aborted.
That's confirmed.
AVI, verify vehicle power is nominal.
Vehicle power is nominal.
OSM, set launch enable to inhibit.
Switching to inhibit.
BC, perform the following steps to get TPC back to manual mode. Set S2 TPC mode to manual and open the S2 fuel vent valve.
Setting stage 2 TPC to manual, opening up fuel vent.
Prop, report when ready to vent the S2 LOX tank.
Prop's ready.
Yeah, could you give us
BC, open the S2 LOX tank vent.
Stage 2 tank vent coming open.
for the next 3 days?
BC, set S1 TPC mode to manual and open S1 fuel vent valve.
S1 TPC going to manual. Fuel vent coming open.
Prop, report when ready to vent the S1 LOX tank.
Prop's ready.
BC, open the S1 LOX tank vent valve.
S1 LOX tank vent valve coming open.
BC, verify close the S1 flight aux fill and drain and the S2 flight aux fill and drain.
It's verified.
DC, verify Dragon has aborted and is in a stable configuration.
Verified.
GC, verify the fill manifolds are vented, S1 and S2 LOX interface, and S1 and S2 RP interface.
Verified.
GC, verify water and deluge ring press valve secured by terminal count abort auto sequence.
Secured.
GC, verify the TVC tank is vented.
TVC tank is vented.
GC, verify T-tap secured by terminal count abort auto sequence and complete the following.
That's in work.
GS, verify data hourly rollover is enabled.
Confirmed.
AVI, determine the need to initiate battery charge sequences.
We do not need to charge.
BC, ticket not perform in step 59.20, battery charging not required. AVI, instruct VC to cycle power on transmitters to keep the temperatures within launch limits.
Copy.
The International Space Station crew has been advised that there was a cutoff in the launch sequence and liftoff did not occur.
23.
Roger. Verifying nominal FTS state.
Copy. Safe and arms are in the safe state. Ordnance interrupters are in the safe state. FTS is on external power, and FTS state is nominal. Is that correct, OSM?
Roger.
LD, the vehicle is safe.
LD copies. As reported by flight software, we had an abort on engine 5 chamber, pressure high. LC, please continue to proceed through scrub securing.
Copy, that's in work.
Okay, thanks so much, guys.
Okay, proceeding to section 10.62. OSM, reestablish roadblocks at the BDA.
In work.
GC, disable the vehicle fill and drain interlock controls.
In work. Complete.
And as we heard, the computer saw a parameter that it didn't like. And that's what that is for. Once ignition occurs, it has a last chance to look at everything to be sure all of the engines and the entire launch vehicle is ready for liftoff. And the computer did see a parameter out of spec, so that did cause the engines to shut down. The vehicle is stable. It's in a safe configuration. And we'll begin a recycle activity once the abort checklist is complete.
LCGC within the scrub site safing auto sequence. Are you ready to raise the strongback?
GC is ready.
LC is ready.
Copy that.
W2-hour turnaround for launch attempt.
Entering 1 to proceed with strongback raise.
See no constraints on the flight hardware that would not allow us to support the target.
Excuse me. Copy. Good work.
Initially, we're planning a 72-hour scrub turnaround. Launch on Tuesday morning. 22nd would be 3:44 a.m.
Are you ready to turn off RF power?
AVI is ready.
RC is ready.
Copy that. Entering 1 to proceed. Prop direct GC to cycle stage 1 fuel bleed FV64 as required.
Copy, will do.
Copy that. LWO provides scrub turnaround and exposure weather forecast. Strongback is at approximately 88 degrees.
Yeah, strongback being returned to vertical, completely flush, adjacent to the Falcon 9.
GC within the strong back raise auto sequence. It's TE vertical and ready to close the cradle. TE is vertical, ready to close cradle. Copy that. Proceeding. GC within the cradle close auto sequence, entering 1 to loosen upper cradle. Copy that.
LC this OSM. Go ahead, OSM. Yes, sir. Do you want to take a couple of sweeps around the pad, make sure that we don't have any fires? Copy, will do. Thank you. VC this LC on the countdown net. Go ahead and move the securing steps to net A.
Copy that.
OSM, this is LC on the countdown net.
This is OSM.
Yeah, we panned around the
This is Falcon 9 Launch Control. We will be having a post-scrub press briefing at 6:30 a.m. Eastern Time this morning. And we will, at that time, be able to provide some insight into the circumstances and also about our next launch attempt, which would be on Tuesday the 22nd. So at this time, this will conclude our coverage until the briefing at 6:30 a.m. Eastern Time this morning. This is Falcon Launch Control.